There was something unusual I noticed when doing some other experiments where an electromagnet attracts iron on this little scale balance. So what I'd like to ask today is, why does an AC electromagnet attract iron, whereas it repels things like aluminium? Let's measure the effect and see what happens. What I have here is a simple 3-beam balance with a wire coil on top, 0.5 millimeter wire, 800 turns, no iron core, just copper, and I'm powering it with an isolation transformer 240 volts and a Variac 240 volts. I'm setting it at 120 for safety, and that wire just goes into both ends of the wire coil so as to create an AC magnetic field, 120 volts, 50 hertz. Now when we turn on the AC power and take a piece of aluminium 6 millimeters thick and put on top of the copper coil, you can feel it vibrating, and you can see quite clearly that the copper coil is being repelled by the aluminium, and this goes up. This is just very standard lens current repulsion. Lens current and the aluminium are an opposite side of the field in the copper, and it's causing repulsion, causing this thing to go up. On the other hand, when we do the same experiment, 120 volts, 50 hertz, and we put a piece of steel over the top, you can see the copper coil is lifting, being attracted to the steel, and that causes the scale to go down. Control, I flip the leads, red for black and black for red, just in case there's any imbalance coming to the power supply. We'll turn on the power again at 120 volts, 50 hertz. You can still see the aluminium is repelling the magnet. You can still hear the humming, and that makes the scale go up apparently. Finally, however, with the lead still flipped, we'll take the piece of iron and put it on top of the magnet. It doesn't repel, but it gets attracted. It lifts the copper coil up toward it, and that makes the scale go down, because the copper coil is lifting up to meet the magnet. There might be various ways to explain this. However, my preferred explanation is as follows. We have paramagnetism induced in the steel or iron by the magnetic field from the copper coil, and that gives a very strong attraction in part of the AC cycle, the DC part, each DC part, but the two parts together cancel, plus and minus, so we should get no attraction at all if that was the only force. However, in addition to that, we can get delayed lens currents in this piece of iron, and they'll be repulsive during any DC cycle. In other words, they'll go the opposite direction as the paramagnetism. But if they keep running a little way into the AC cycle, which is only 1/50th of a second, this is 50 hertz, then they'll be attracted to the AC field when it flips. In other words, there'll still be some currents going here, which will get attracted to the flipped field of the wire coil.